So the next concept that we are talking is basically the factor theorem and remainder theorem. So now when you have been given a polynomial, let's say if you've been given a polynomial p of x, and if you divide, let's say by factor x minus a, you get certain quotient q of x and you get certain remainder. Now, according to the factor theorem, the remainder is straight away p of a. So when you divide a polynomial p of x by x minus a, the remainder of this is nothing but straight away p of a. Now, what does it mean is that suppose, let's say if I'm dividing a polynomial x squared minus 3x plus 4 by, let's say, x plus 5. Now, when I long divide this, let's say here it will be x squared plus 5x. So if I subtract this, you'll get negative 8x plus 4. You get negative 8 here. So negative 8x minus 40. And then you get positive 44 as the remainder. Now, if I would have done the same thing by just taking p of minus 5. Now, p of minus 5 means I plug minus 5 here, and let's see what we get. So minus 5 squared minus 3 times minus 5 plus 4. So what happened is you get 25 plus 15 plus 4, which is nothing but 44. So you can see that both the remainders are the same. So as per the polynomial rule, now if you have a factor like p of x, you're dividing by, if you have a polynomial and you're dividing by x minus a, the p of a is the factor, is the remainder. Now, if p of a is basically coming to 0, it means that this x minus a is a factor. So if the remainder is 0, it means x minus a is a factor of this polynomial. We'll discuss in that next question. Well, let's take the first question where we talk about the factor theorem. The remainder theorem. So the remainder of the polynomial f of x when it's divided by x plus 1 is 7. And it is when it is divided by x minus 2, it is 1. And you have to find out the value of p and q. So first thing is that we just discussed p of minus 1 as it is 7. And p of 2, it is 1. So that helps us set up two equations. When I plug x as minus 1 here, we get is negative 1 to the power of 4 p times negative 1 the whole cube, q times negative 1 plus 5 equals to, let's say, this is equals to 7. And so that results in 1 minus p minus q plus 5 equals to 7. So you get p plus q equals to, let's say, 5 comes this side, so this is 6 here. So that'll be p plus q is actually going to be equals to, let's say, negative 1 here. So this is 6. The 6 comes this side, is 7 minus 6, 1. And then I took minus common, so that's how I got it. P plus q is negative 1. Similarly, if you take x as 2 here, so it'll be 16 plus 8p plus 2q plus 5 equals to 1. So we get the second equation as 8p plus 2q equals to basically 5 plus 16, that's 0, 21 and 21. So 1 minus 21, so that's negative 20. So as a result of this, we get two equations, p plus q is negative 1 and 4p plus q equals to negative 10. And if you solve these equations, so you get here, negative 3p is equals to 10. So p is negative 3. And once you got p as negative 3, you can plug in an equation here. So let's say I plug here negative 3 plus q is negative 1. So q is nothing but positive 2. So this is how you got the, you use the remainder theorem. Now let's talk about the second question, that is about the remainder theorem, the factor theorem. So remainder theorem is, the factor theorem is one of the cases of the remainder theorem where if you're dividing a polynomial p of x by x minus a, and if your remainder is coming to 0, then p of a is a factor. We say that, or p of a, if it is coming to 0, then we call that x minus a is a factor of p of x. So let's just have a look at this example. The polynomial x to the power 4 plus px cubed plus qx squared plus rx plus 6 is exactly divisible by each of p, q, and r, and where x is 1, x is 2, x is 3. So find out the value of p, q, r. So what we do is, you plug x as 1, you get the first equation. And obviously plug x as 1 and equate that answer to 0. Plug x as 2, equate the answer to 0, you get second and third. And you can just solve this equation simultaneously, either manually or put on the calculator to get the value of p as negative 7, Q as 617, and R as negative 17.